Suppose that in a science test, Sam scores 92 marks out of 100 and Sela scores 170 out of 200. Who do you think has a better score, Sam or Sela? Sela's marks may seem better than Sam's marks, but we cannot decide whose score is better only by comparing their marks. This is because the maximum marks out of which they have scored 92 and 170 are different. Or in other words, the fractions representing their marks have different denominators. Hence, these fractions cannot be compared directly. To find out who has scored better, we must first express these fractions with a common denominator. Let's first convert the denominator of both the fractions to, say, 100. A fraction with denominator 100 is called percent. Percent is a Latin word which means per hundred. It is denoted by the symbol shown here. Percentage is another way of comparison. It will help us decide who has scored better. Thus, in case of marks scored by Sam and Sela, the percentage of marks obtained by Sam is 92 over 100, which is 92%. Sela's score can be reduced to 85 over 100, which is 85%. Thus, we have calculated marks in terms of percentage, which can now be compared. We can say that Sam has scored 92%, which is more than Sela's score of 85%. This is how percentage is used to compare quantities. Percentages are also used to express how large or small one quantity is relative to another. For example, when we say that 71% of Earth's surface is covered by water and the remaining 29% is covered by land, we get an idea of the relative distribution of land and water on Earth's surface. Let's now solve a few problems involving percentage. 100 students of a school play sports. 30 students play soccer. 45 play basketball and 25 play tennis. What is the percentage of students playing each sport? Since percentage is essentially a fraction with denominator 100, we will find the fraction for each sport, which will give us the percentage. We know that 30 students out of 100 play soccer. Therefore, the fraction for soccer will be 30 over 100. Similarly, fractions for basketball and tennis will be 45 over 100 and 25 over 100 respectively. Thus, their percentages will be 30, 45 and 25 respectively. Now try to find these percentages. In a shop, there are 15 bottles of grape juice, 37 bottles of pineapple juice, 23 bottles of orange juice, and 25 bottles of guava juice. Find the percentage of bottles of each flavor. First, the total number of bottles is calculated, and then the percentage of bottles of each flavor is found. So far, we have seen how to calculate the percentage when total items add up to 100, that is, 100 students, 100 juice bottles, etc. But what if the total items do not add up to 100? Well, in such a case, the denominator of the fraction must be converted to 100. Let's understand this with an example. 25 books are placed on a table. Out of these, 10 books are on science and the remaining 15 are on history. Find the percentage of books on both the subjects. As done earlier, first we find the fractions for books on both the subjects. Books on science are 10. Therefore, its fraction is 10 over 25. Similarly, the fraction for books on history is 15 over 25. Denominator of these fractions is 25. For calculating percentage, the denominator must be converted to 100. Therefore, we convert each of these fractions to an equivalent fraction with denominator 100. This conversion can be done by multiplying the denominator and the numerator with 4. Thus, we find the percentage of books on both subjects. So far, we have learnt how to express fractions as percentage in various cases and situations. All of them were proper fractions. Now, let's see what happens if an improper fraction is converted to percentage. Sam and Sela together ate one complete pizza and 3/4 of another pizza. This amounted to the fraction 1 and 3/4. Express this fraction as percentage. First, we convert the mixed fraction to an improper fraction. Then, we multiply and divide by 100 to find the percentage. The term 1 over 100 is replaced by the percent symbol. Further simplification gives us the percent value. Observe that the improper fraction 1 and 3 over 4 has resulted in a percentage greater than 100. Can we really have percentage greater than 100? Let's find out. Suppose we say that a contestant answers 140% of the questions asked to him in a quiz. This does not make any sense because the contestant cannot answer more than the questions that are asked. On the other hand, if we say that the number of questions asked in the second round of the quiz increased by 120%, it makes perfect sense. For example, if the number of questions asked to a contestant in the first round of quiz is 10, and the number of questions asked in the second round is 22, then the increase in the number of questions asked in the second round is 120%. Since a fraction can be converted to decimals, a decimal too must be expressible as percent. Let's learn how to convert decimals to percentage with the help of examples. Look at this 1 kilometer long road. 0.4 kilometer of this road has plantation along its sides. We have to express this part of the road in terms of percentage. To convert decimals to percentage, we simply multiply with 100. Therefore, 0.4 is equal to 0.4 multiplied by 100%. Thus, 0.4 is equal to 40%. Now, try to convert this decimal to percentage. .07 is equal to 7%. Since percentage is a fraction with denominator 100, percentage can be converted back to fraction by taking the denominator as 100. Let's understand this with an example. Look at this circle. It represents the percentage of gases in the atmosphere. Let's find out the fractional value of these gases. Since percent means per 100, we can write 78% as 78 over 100, which can be simplified to 39 over 50. Similarly, oxygen is 21 upon 100, and other gases can be expressed as the fraction 1 over 100. We will now convert percents to decimals. 30% of this circle is shaded with blue color. Let us find the area in terms of decimals. Again, percent means per 100. Therefore, 30% is written as 30 over 100. We know that 30 over 100 is 0.30. Let's now convert 150% to decimal form. We know that 150% is the same as 150 over 100. The fraction 150 over 100 is reduced to the fraction 3 over 2. Thus, 150% is equal to 1.5 in decimal form. Now, try to find the decimal form of 43%. %43 is equal to 0.43 in the decimal form. The concept of percentage is also used to estimate the parts of an area. Let us see how. The fraction of the area shaded in green is given to us. From this fraction, we can find the percentage of the shaded part. We multiply this fraction with 100 to find the area in percentage. Thus, percentage of area shaded in green is 25. Now, can you try to find the percentage of the area shaded in red? Again, the fractional value of the area shaded in red is given to us. We multiply the fraction with 100 to find the area in percentage. On simplifying, we get the area shaded in red as 12.5%.